So guys, now we have to continue that topic which is maxima and minima. Already we studied about in a previous 2 to 3 lectures what is maxima and what is minima, and some examples which is depend on maxima and minima. Up to example number 4th example we take the topic, we continue that maxima and minima. So here the next example number 5, which is maxima and minima. Two sides of a triangle are given here. In example number 5 given that there are the two sides of a triangle. The total sides of a triangle is 3 sides, and in these 3 sides, 2 sides are given. Find the angle between them such that we have to find the angle between them, which is angle between two sides. Find the angle between them such that the area of triangle is maximum. We have to find angle between these two given sides when the area is maximum. So here, if we consider that if any triangle, the name of triangle which is PQR, or we can say that let ABC be any triangles. The side which is opposite to angle C is C. The side which is opposite to angle B is B, and the side which is opposite to angle A, which is A. Let us consider that length of AB is C, length of BC is A, and length of AC is B. Here any two sides are given. Let us consider that any two sides. Later we consider that AB and BC are given. Let AB is equals to C and AC is equals to B are given. The length of AB is C and length of AC is B. These two sides are given. We have to find the angle between these two sides, AB and AC. AB and AC, these two sides, AB and AC, make angle BAC or CAB. We can consider that this angle is x degree. So, if we consider that this angle A is x, so here we have to find the area of triangle is maximum. Let us consider that. Let again del be the area of triangle ABC. We consider this del is the area of triangle ABC. So here we have to find angle between them such that the area of triangle is maximum. So we consider the value of A is x, and here if del be the area of a triangle ABC, then we know that area of triangle ABC or del is equals to half of side which make angle B and C, BC, into sin A. The angle ABIX, we can write this sin x. So here we know that we have to find the angle between them. The area of triangle is maximum. Let us consider that del is equals to 1 by 2 BC sin x, which is equation number 1. If we differentiate equation number 1 with respect to x, then we can write del upon dx is equals to del upon dx, derivative of right side which is 1 by 2 BC, which is constant function, and we have to take a derivative with respect to x, is sin x. So derivative of sin x is cos x. We can write d del upon dx, d del upon dx is equals to 1 by 2 BC, the derivative of sin x, which is cos x, equation number 2. So we know that the area of triangle is maximum. We can write for maximum area for maximum area, which is d del upon dx is equals to 0. If we substitute the value of d del upon dx is equals to 0 in equation number 2, we can write 1 by 2 bc into cos x is equals to 0. So if we transfer this value bc upon 2, right side we can write cos x is equals to 0 into 2 upon bc. If we multiply it any function for 0, then we get whole value is again 0. So here we can write cos x is equals to, we know that the value of cos pi by 2 is equals to also 0, then we can say that therefore x is equals to pi by 2. Here we can write therefore x is equals to pi by 2. The value of x, that is angle A, is equals to pi by 2. The angle A is equals to pi by 2. So now differentiate equation 1 with respect to x. Sorry, equation 2. If we differentiate with respect to equation 2, then we get second order derivative d2 del upon dx square is equals to 1 by 2 bc into derivative of cos x, and derivative of cos x is minus sin x. We can write 1 by 2 into bc minus sin x. If we substitute the value of x, which is pi by 2, then we can write minus bc upon 2 into sin of pi by 2. Sin of pi by 2. We know that the value of sin of pi by 2 is 1. Hence we can write it minus bc upon 2, which is d2 del upon dx square is strictly less than 0. If second order derivative d2 del upon del x square is less than 0, then we can say that a is equals to pi by 2 or x is equals to pi by 2 when area of triangle, when second order derivative d2 del upon del x square is less than 0, we can say that area of triangle is maximum. Area of triangle is maximum. So the value of when the angle between them such that area of triangle is maximum, then also we can write hence the area of a triangle is maximum. Triangle is maximum. Area of a triangle is maximum when the angle between given side, when angle between given side is pi by 2. Or secondary we can write sin A is maximum when A is equals to pi by 2. So here the required answer, the area of triangle when maximum, the angle between the given side is pi by 2. So here the required angle which make two sides of a triangle is pi by 2 when area is maximum. So the example number 6 is the side of right circular cone. Here given any sides of right circular cone is L. So here L is given, which is side of right circular cone. Show that the semi-vertical angle of the cone of maximum volume is a tan inverse of under root 2. Here we have to show that semi-vertical angle of a cone of a maximum volume is tan inverse of under root 2. It is clear that here, if we consider that this figure is any circular cone. So here let us consider that it is any circular cone. It is the center of this circular cone and distance from center we denoted that radius small r. Let r be the radius. Height of the circular cone bx is given. So let us consider that r be the radius. We can consider that x be the height of circular cone and length of the circular cone, which is L. So here we consider that let r be the radius of circular cone, x be the height of circular cone, L be the length of circular cone, again V be the volume of circular cone. So here we have to show that semi-vertical angle of the cone of maximum volume is tan inverse of under root 2, and we know that here a radius by using Pythagoras theorem, because here it make angle right angle triangle, and by using Pythagoras theorem in this triangle we can say that therefore L square is equals to x square plus r square, or r square is equals to L square minus x square, which is equation number 1. So now if we consider that V be the volume of circular cone, and we know that V is equals to volume of circular cone, which is V is equals to 1 by 3 pi r square x. 1 by 3 pi r square x. So now we have to substitute the value of r square is L square minus x square. If we write this 1 by 3 pi L square minus x square into x, so which is the volume of circular cone. Now we have to multiply this bracket by x. We can write 1 by 3 pi L square x minus x cube. So if we differentiate with respect to x by v, we can write dv upon dx is equals to 1 by 3 pi is constant function. We take a derivative of L square x minus x cube. So if we take L square constant function, we can write 1 by 3 pi derivative of x, which is 1, L square into 1 minus 3x square. So which is 1 by 3 pi L square minus 3x square, which is dv upon dx. We can write for maximum volume, here we have to find by using maximum volume, which is dv upon dx is equals to 0. If we substitute the value of dv upon dx is 0, we can write 1 by 3 pi L square minus 3x square is equals to 0. So now we have to shift this 1 by 3 pi or pi by 3 right side. We can write L square minus 3x square is also 0, because this pi by 3 into 0 become also 0. So here if we shift this minus 3x square right side, we can write 3x square is equals to L square. So we have to shift this 3 right side, we can write x square is equals to L square upon 3. So if we take square root both side, taking square root both side, we can write the value of x, which is plus or minus L upon under root 3. But value of x, which is height of the cone, height is not negative, we can say that, but x is not equals to minus L by root 3. Hence, the clear value of x, which is plus L by root 3. So now we take this equation number 2, which is dv upon dx. If we differentiate equation 2 with respect to x, then we get the second order derivative d2v upon dx square is equals to 1 by 3 pi is constant function. The derivative of L square is constant, again 0, minus 3 into 2, which is minus 6x. Derivative of 3x square is minus 6x. We can write it minus 1 by 3 pi into 6x, which is 3 is 1, 2, minus 2 pi x, which is less than 0. The second order derivative, which is d2v upon dx square, minus 2 pi x, and the value of minus 2 pi x, which is negative value, means we can say that it is less than 0. So hence we can say that volume of the cone, hence volume of the cone, when volume of the cone is maximum when height of the cone, which is x, is equals to the value of x is L upon under root 3. So we have to show, but here we have to show that the semi-vertical angle of the cone of maximum volume is tan inverse root 3. So if we consider that, let alpha be the semi-vertical angle, and that is we can write the value of alpha, which is semi-vertical angle, means r upon x, radius upon height. So here the value of x is already, which is L upon root 3. Now we have to find the value of r. If we have to find the value of r, then we have to substitute the value of, which is equation number 3. We have r square is equals to L square minus x square. The value of x, which is L square minus L upon under root 3 whole bracket square, means L square minus L square upon 3. So we can write 3L square minus L square, which is 2L square upon 3, which is the required value of r square. So, it is tan alpha is equals to r by x. So here we can evaluate the direct value of r, that is r square is equals to 2L square upon 3. That is the value of r is equals to plus or minus under root 2L upon under root 3. But here r is a radius and radius is not negative, hence we can write, but r is not equals to minus L root 2 upon under root 3. That is the required value of r is L root 2 upon under root 3. Here we have to substitute this value of r and x in equation 3. Therefore equation 3 become tan alpha is equals to the value of r, which is L root 2 upon under root 3, upon the value of x, which is L by root 3. Here root 3 get cancelled. Tan alpha is equals to L root 2 upon L. Here L get cancelled. Tan alpha is equals to under root 2, which is a required proof. If we shift this root to right side, we can get alpha. If we substitute this, if we replace this tan right side, we can write alpha is equals to tan become tan inverse of under root 2. Here we consider alpha is semi-vertical angle. So we can write semi-vertical angle alpha, which is tan inverse of root 2. Semi-vertical angle, which is tan inverse of root 2 when volume is maximum. So we can write it, when the volume is maximum, then semi-vertical angle is tan inverse of root 2, hence proved. Guys, example number 7 is, find the height of the covered box. We have to find here height of the covered box. Fix the volume so that the total surface area of the box is minimum, whose base is a rectangular with one side 3 times as long as the other. So here we have to find height of the covered box, and the given covered box is a rectangular shape. So we can write it. So here we can write it, given that box is a rectangular shape. The given box is a rectangular shape with one side is 3 times than other sides. So here, if we consider that, let X be a one side, then 3x be a opposite side. So we can write x be a x and 3x. So therefore we can write x and 3x be a sides of a rectangle. So here we can write, again let us consider that h be a height of rectangle and v be a volume of rectangle. We know that the volume of rectangle, which is side where x, 3x and height h, then we can write therefore v is equals to x into 3x into h. So we can write it 3h into x square, or we can write 3 into x, which is 3x square into h, which is v. If we differentiate this function with respect to x, then we can write h is also differentiable function because h is a height, means any one of the side of rectangle. So we can write dv upon dx is equals to 3 is constant function. By using u into v rules, we can write x square into derivative of h plus h into derivative of x square. So it is 3 into x square h plus 2xh. So by the observation, in given condition, we can say that given that the fixed volume, so that the total surface area, here the volume is fixed, means volume is constant. So if the volume is constant, then we can say that dv upon dx is also derivative of constant function, means volume is 0. We can write it dv upon dx is equals to 0. So therefore we can write 3 into x square h plus 2xh, x square into dh upon dx, x square into dh upon dx plus 2xh is equals to 0. So we can write it, if we shift this to the right side, we can write x square into dh by dx is equals to minus 2xh plus 2xh, convert into minus 2xh. So dh upon dx is equals to minus 2xh upon x square. If we cancel this 1xx, we can write dh upon dx is equals to minus 2h upon x, which is the required derivative of dh upon dx. But here, if we consider that, let S be the surface area of a rectangular box, then we can say that S is equals to the value of surface area, S is equals to 2 plus 3x square plus 2 plus 3xh plus 2 into xh. So we can write it 2 plus 3x square plus 2 plus 3xh plus 2 plus 2 into, it is 2 into 3x square. We can write it, the calculation of 2 plus, which is the surface area 2 into 3x square plus 2 into 3xh plus 2 into xh. That is, we can write after calculating whole value 6x square plus 8xh, 6x square plus 8hx. Because 2 into 3x square, which is 6x square, plus 2 into 3xh, which is 6xh, plus 2 into xh, which is 2xh. Sum of 6xh plus 2hx is 6x square plus 8xh, which is the surface area. If we differentiate this surface area with respect to x, then we can write a derivative of s, means surface area ds upon dx is ds upon dx is equals to 6 into derivative of x square plus 8 is constant. X and h be both differentiable function by using u into v's rules. X into dh upon dx plus h into derivative of x. So we can write it 6 into derivative of x square is 2x plus 8 into x into dh by dx plus h into derivative of x, which is 1. So we can write it 6 into 2, 12x plus 8x dh upon dx plus 8h, which is a value of ds upon dx. Means if we substitute the value of dh upon dx is minus 2h upon x, we can write 12x plus 8x into minus 2h upon x plus 8h. Here x get cancelled, we can write 12x minus 8 into 2, 16h plus 8h. So we can write it 12x minus 16h plus 8h, which is minus 8x, which is ds upon dx. So we have to calculate that. For a minimum surface area, we can say that for minimum surface area ds upon dx is equals to 0. Then we can write it 0 ds upon dx means 12x minus 8h is equals to 0. So if we have to find the value of h, we can shift this minus 8h right side. We can write 8h is equals to 12x. Now we have to transfer this at right side. We can write h is equals to 12x upon 8. We divide and multiply it. Numerator and denominator, if we divide by 4, we can write 4 into 2, 8. 4 into 2, 3, 12. We can write 3x upon 2, which is h. Here the value of h is greater than 0. And also the value of x is also greater than 0. So we can say that for the value of x and h, both are positive. If we differentiate equation 2 with respect to x, we get the derivative of surface area ds, which is d2x upon dx square. After differentiating equation 2, we get the derivative of s, which is d2s upon dx square is equals to, again the derivative is constant function, 12 into derivative of x minus 8 into derivative with respect to x of h. We can write it 12 into 1 minus 8 into dh upon dx. the rate of change of the value of dh upon dx, if we calculate that, minus 2h upon x, we can write 12 minus 8 into minus 2h upon x. So here 12 minus plus 8 into 2, 16h upon x, which is d2s upon dx square. So here h and x, here h and x, both the functions are positive, then we can say that d2x upon dx square is also positive, means greater than 0. So here d2x upon dx square is greater than 0. So because x and h both are positive, so here we can write surface area of box is minimum. Surface area of box is minimum when height h is equals to 3x by 2 and if height 3 by 2 into shorter side of the base, or we can write 3x by 2, 3 by 2 into shorter side of the base.